So a single replacement reaction, this is on your notes sheet, so you want to get that out and just kind of follow along with the video and then do the examples that I do. So a single replacement reaction is when a free element replaces another element in a compound to make a new compound and a new free element. So for example, B is our hypothetical element that's by itself, in other words the free element, and then this would be a compound, and that's pretty much always going to be an ionic compound, so you would have positive ion and a negative ion. And so depending on what B is, whether it's a metal or a nonmetal, that's going to determine which of these two, in this case A or X, it's going to try to replace. So if you look at the next two sentences, it says if the free element can form a cation, and if you remember, metals form positive ions or cations. If that's the case, if B is a metal, it's going to replace the metal or the cation in the compound, which is always going to be the first one. If this is a nonmetal, it's going to try to replace the second thing, which is going to be another nonmetal. So let's take a look at what an example would look like. So let's say we have lithium by itself, and I have, let's say, sodium oxide. So I have a free element and a compound, and that's how I know that this is going to be single replacement rather than, combustion or synthesis or decomposition. Free element and a compound. And so in this case, the free element lithium is a metal. It's from the left-hand side of the periodic table. If I bring a periodic table over, you can see lithium is way over here. Okay? It's a metal. So it's going to form positive ions. In fact, when it does form ions, it forms +1 ions. So what that means is it's going to try to replace the positive ion in the compound. So lithium is going to try to replace sodium. So if that happens, you're then going to have lithium paired with oxide, or oxygen, but we call it oxide because it's an ion in this case. And then we look at the charges, and because lithium is +1 and oxide is -2, again, just looking at where they sit on the periodic table, that means I'm going to need 2 lithiums for every 1 oxygen. And that also means that sodium, because lithium kind of came in and replaced it, sodium is now by itself. And metals are never diatomic. If you remember your list of diatomic elements, Brinkelhoff or Hoff-Brinkel, or however you memorize those diatomics, when a metal is by itself, it never has a subscript because none of the metals are diatomic. Okay, but we do have to look and make sure that this thing is balanced. And I'm going to erase my charges and all this extra stuff. In this case, it doesn't look like it is balanced because I have 2 sodiums on the left, so I need a coefficient of 2 in front of sodium on the right. Same thing with lithium. I have 2 on the right, so I need to put a 2 out in front of lithium on the left. Now, if you'll look at this note here, it says the free element on the reactant side must be more active than the element it's replacing. So let's talk about what that means. What that is saying is lithium has to be more active than sodium, and active just basically means reactive. So lithium has to be more reactive than sodium. How do you find out? Well, that's where you go to the activity series, which is this long list of metals on the right-hand side of your paper. And if you'll look here, lithium is the very top of the list, and that means lithium is the most active metal. So that means lithium can replace any other metal in one of these single replacement reactions. So anytime lithium is the element that's by itself to start with, it's always going to work. It's always going to be a reaction. If it weren't, then we would simply say no reaction. Okay? So in other words, if I try to do the reverse reaction, so let's say instead, basically I'm starting with sodium by itself, and I have, let's say, lithium oxide. Well, this is going to be a no reaction in R. And the reason it's a no reaction is because sodium is the element that's by itself. It's going to try to replace the metal in this compound, because sodium is a metal, which is lithium. And if I look over here at my activity series, sodium is below lithium. So sodium cannot replace lithium because lithium is above it. So that would be a no reaction. Okay, try this one on your own. See if you can predict whether or not the reaction happens. And then if it happens, figure out what the products would be and balance the equation. Okay, so let's say I have calcium reacting with zinc phosphate. Sorry. Okay, so you should have predicted that this will happen because calcium is up here, zinc is a little ways down, it's down here, so calcium will be able to replace zinc. So calcium is going to come in here and replace zinc, and that's going to result in calcium now being paired up with phosphate. Now remember, don't automatically bring over the subscripts. So don't automatically bring over this 2. We have to look at the charges on calcium and phosphate before we can decide what the subscripts will be. So calcium is in group 2 of the periodic table, so it's +2. Phosphate, hopefully you have memorized, it is -3. And so we are going to get 3 calciums and 2 phosphates. And I am done with these charges, so I'm going to get rid of all that mess. And then my other product, of course, don't forget to write. Your other product would be zinc, which is, again, off by itself. So it has been sort of kicked out of the compound. We do need to balance, though, and it looks like we need 3 zincs, and it looks like we need 3 calciums. Okay. All right, let's try one more like this, and then we'll talk about what happens when a nonmetal gets replaced. Okay, what do you think is going to happen here? Okay, so CO is cobalt. Cobalt is a metal, so it's right here on the activity series. It's on the left-hand side of the periodic table. Cobalt is right there, element number 27. So it's a metal, so it's going to try to replace the metal aluminum in the aluminum nitrate compound. So then you just have to decide which one is higher. I changed this up a little bit by writing the compound first. It doesn't matter which one you write first. I had been writing the elements first. This time I wrote the compound first. But it doesn't really matter which order you put them in. It's still cobalt trying to replace aluminum because they're both metals. Okay? And so then you have to decide, all right, will cobalt, the thing that's by itself, is what you always want to be higher on the list. Is cobalt higher on the list than aluminum? And the answer in this case is no. Aluminum is above cobalt. So if aluminum is above cobalt, cobalt can't replace aluminum, so this is going to be an NR for no reaction. Okay. So we don't have to balance it, obviously, because there's no products, because there's no reaction. Then the last thing we have to talk about is, okay, what if it's not a metal that's by itself? Let's say we have a situation like this. Chlorine reacting with sodium fluoride. So chlorine is Brinkelhoff, so that's why I put the 2 there. So in this case, chlorine is a nonmetal. It's way over on the right-hand side of the periodic table in group 17. Okay, so it's a nonmetal. So it's not going to try to replace the metal like the previous ones did. It's not going to try to replace the sodium. It's going to try to replace the fluorine, okay, or fluoride in this case because it's an ion. So the question is, will chlorine be able to replace not sodium, but will it be able to replace fluoride? And you'll notice neither of those 2 elements are on the activity series because the activity series is all metals, with the exception of hydrogen, which kind of acts like a metal for the sake of these reactions. Everything else on this list is a metal. So chlorine and fluorine are not found on this list. So how do we decide if chlorine is going to be able to replace fluorine? And the answer is we don't have a separate activity series for the halogens. Chlorine and fluorine are both halogens, are in group 17, because the periodic table itself acts as an activity series. So when chlorine tries to replace fluorine, because chlorine is lower on the periodic table, chlorine will not be able to replace fluorine. Okay? So this is going to be a no reaction because chlorine is below fluorine on the periodic table. So NR. Now, when it comes to the nonmetals doing single replacement reactions, you're only going to ever have to worry about halogens. And that's why the periodic table is so useful, because all you have to do is look at this group, group 17. So it's always going to be like bromine replacing iodine, or fluorine replacing bromine, or something like that. You're never going to have to worry about oxygen or nitrogen or sulfur or any of the other nonmetals. Okay? So let's do another example here and see if you can figure this one out on your own. Let's say we have lithium bromide plus I2, iodine. So first of all, will it be a reaction? If so, what are your products and balance? Okay, and if we look at a periodic table, the question is, iodine is it's a halogen, so it's going to try to replace not the lithium, but the bromine, the other halogen. And if we look at the periodic table, iodine is below bromine, so iodine cannot replace bromine. So this is going to be another no reaction. So there you go. When it's a metal, you're going to use the activity series. When it's a non-metal, you're going to it's going to be a halogen, and you're going to be using the periodic table to predict whether or not it's a reaction. And then it just comes down to, if it is a reaction, predict the products and balance.